In this example, we need to solve 2x over x minus 3 plus 4 over x plus 3 equals negative 24 over x squared minus 9. Well, what type of equation do I have here? I have a lot of denominators. It's a rational equation. How do we solve rational equations? We find the least common denominator, and then we're going to multiply all three terms of our equation by the least common denominator, and that will get rid of all our denominators. Well, to find the least common denominator, I have to make sure all my denominators are factored. X minus 3 is factored, x plus 3 is factored, but how about x squared minus 9? No, this is not factored. So the first thing we need to do is factor x squared minus 9. There's no common factors between x squared and 9. And how many terms do I have? 2 terms. The first term is a square, the last term is a square, and it is the difference of 2 squares. So remember, the difference of 2 squares always factors into 2 binomials. The first term in each binomial is the square root of x squared, which is x. There are opposite signs in the parentheses, and the last term is the square root of 9, which is 3. So x squared minus 9 factors into x plus 3 times x minus 3. So now all our denominators are factored. We can find the LCD. To find the least common denominator, go to the first denominator. I have to have an x minus 3. You go to the next denominator. Do I have an x plus 3 over here? No. So I have to multiply by x plus 3. Now go to our last denominator in factored form. Do I already have an x plus 3 present? Yes. Do I already have an x minus 3 present? Yes. So my LCD is x minus 3 times x plus 3. The next thing we need to do is find out the restrictions on the variable. What values of the variable make a denominator equal to 0? So to find that, we set our LCD equal to 0. So I have x minus 3 times x plus 3 equals 0. Two numbers multiplied together equals 0. Set each of them equal to 0. So I get x minus 3 equals 0 and x plus 3 equals 0. The first one, x minus 3 equals 0. Add 3 to both sides. I get x equals 3. The second one, x plus 3 equals 0. Subtract 3 from both sides. I get x equals negative 3. So what are my restrictions? We know that x cannot equal negative 3 and positive 3. The next step is where we multiply every single term in our equation by the least common denominator. This takes a while to write out, so I'm going to put it on pause for a second. So I took each of the terms in my original equation and I multiplied it by the LCD over 1. And the term on the right-hand side, notice I wrote the denominator in factored form. So now I'm ready to simplify. And on the first term, my x minus 3 reduces, and I get left with 2x times x plus 3, plus on the second term, x plus 3 reduces, and I get left with 4 times x minus 3. And on the right-hand side, my x minus 3 is reduced, my x plus 3 is reduced, so I get negative 24 times 1, which is negative 24, divided by 1 times 1, which is 1, so I just get left with negative 24. So now we need to simplify this, so let's distribute in the 2x. 2x times x is 2x squared. 2x times 3 is plus 6x. Now distribute in the 4. 4 times x is plus 4x, and then 4 times negative 3 is negative 12, equals negative 24. And what type of equation is this? The highest exponent on the x is a 2, so it's a quadratic equation. And how do we solve those? We need to get everything on one side, 0 on the other. So I'm definitely going to have to add 24 to both sides. And negative 24 plus 24 on the right is going to give me my 0 on the right-hand side. And now on the left-hand side, I have 2x squared. I have 6x plus 4x, that's plus 10x. Excuse the bad handwriting. Negative 12 plus 24 is plus 12. So I have 2x squared plus 10x plus 12 equals 0. So this is in standard form. Everything is in descending order on the left, and I have 0 on the right-hand side. So now we're ready to try and factor this, but since I'm running out of room, I'm going to put it on pause. On this next slide, I wrote the original equation. I wrote the equation I got on the bottom of the previous slide, and I also rewrote the restrictions. So now we need to factor 2x squared plus 10x plus 12 equals 0. The first thing with any factoring problem, is there a greatest common factor? Well, my numbers are 2, 10, and 12, so I can definitely pull a 2 out. They don't all have an x in common, so my GCF is a 2. Pull a 2 out of 2x squared is going to leave x squared. Factor a 2 out of a 10x, it's going to leave plus 5x. And factor a 2 out of a 12 is going to leave plus 6 equals 0. So now I'm going to factor this trinomial. And to factor it, we compare it to ax squared plus bx plus c. What is the coefficient in front of the x squared that we're too efficient to write? It's a 1. So I know a is 1. B is the coefficient of the x term. It is 5. And c is the constant term, it is 6. So we multiply a times c, it's 1 times 6 is 6. So I need two numbers that multiply to ac, or 6, and add to b, which is 5. As they multiply to a positive, my numbers have the same sign, and they add to a positive, both signs have to be positive. So I start with 1 and 6. 1 times 6 is 6, but 1 plus 6 equals 7. Didn't work. 2 divides into 6 3 times, so 2 times 3 is 6, and 2 plus 3 equals 5. Is that the number I'm looking for? Yes. Now, since a is 1, these are my factors. So I'm going to have 2 times the quantity x plus 2 times my other one is x plus 3 equals 0. So I factored my expression. Now I have three numbers multiplying together equals 0. You set each of them equal to 0. So 2 equals 0, x plus 2 equals 0, and x plus 3 equals 0. So looking at the first one, can 2 equal 0? No. From x plus 2 equals 0, you're going to subtract 2 from both sides and get x equals negative 2. And from x plus 3 equals 0, subtract 3 from both sides, you get x equals negative 3. But remember, we're not done yet. We have to compare our answers to our restrictions. Remember, the two values of x that were not allowed because they made at least one denominator 0 was x equals negative 3 and x equals 3. So one of my solutions was x equals negative 3. That is not allowed. That is an extraneous solution. But is x equal negative 2 allowed? Yes, it's not one of my restrictions. So I have one solution to this equation. We've shown that x equals negative 2 is not extraneous, but to prove you have the problem totally correct, you take negative 2 and plug it in for every x value in your original equation and see if you land up with a true statement.